All right. Well, thanks everyone for coming. Who was in the Maven talk, the Accelerate Maven talk? I don't know what, 2 hours ago. A lot of folks. All right. A lot of Maven love here. I appreciate that. All right. So this is Maven 102. So 102 being kind of the next baby step above 101. Right. So I'm not going to get too far into the weeds, but hopefully I'll give you enough information of things you can go back and Google. Right. But we're going to talk about hopefully kind of Maven demystification. So hopefully you'll learn a few things as we go. I'm going to touch on the Maven build lifecycle. I'm going to give you some tips and tricks, and then hopefully I'll make you laugh along the way. If I don't, I'm going to apologize now, but you know, you could pretend to laugh maybe. All right, so first up, who's this guy? This is me. I'm Brian Demers. I'm a developer advocate at Gradle. So if that confuses you, hold on, I'll explain that in a minute. But most of my career has been in and around open source communities, kind of in the Java world, in the spaces coming to application security and build tools, right? And those don't seem related at all to some folks, right? Until you start thinking about your build connects to the internet or your intranet, and there's probably some authentication involved there. So that's how I got involved in those two spaces, kind of doing some security layers for application and connecting to build tools. So outside of all of this, I live in the States. I live in the northeast part of the U.S. and in New Hampshire, and I have bees. So I have honeybees back in New Hampshire that are booming right now. It's a spring buildup, and they're going crazy. I've been stung, I don't know, 4 or 5 times already this year, so it's a good year. All right, so I like to start off with a little bit of game. So raise your hand if you're a fan of tabs. Okay, no spaces. All right, spaces win. I'm in the spaces camp. All right, this is a harder one. Dogs. Uh-oh. Cats. I was like half and half. All right, you can kind of like both. It's fine. So this is my dog, Zemo. It's kind of an older picture, but he's a big dog. He's like almost 50 kilos. And this is just some random cat picture I found on the internet. I'm allergic to cats. My wife really wanted a cat, so we compromised and got a giant dog instead. All right, so who saw this coming? Right? So raise your hand for Gradle build tool. That's what I expected. It's fine. And then Maven, right? All right. Well, I was going to suggest you go to a different talk otherwise. All right, so why is a guy from Gradle talking about Maven? Well, they write my paycheck for one, right? So Gradle, is this elephant in this room here? Right. So whenever we hear Gradle, we think of the Gradle build tool. We also have a product called Develocity, and that's all about speeding up your builds. And it works for Maven, Bazel, SBT, and of course, Gradle build tool. This talk is not about that, but that's why I'm here. I very much prefer Maven. But in general, Gradle, the company, doesn't care which build tool you're using either, as long as you're productive. Okay, so enough of that. So most of the complaints I hear about Maven are related to XML. Anyone disagree? No? Last night I was having this conversation, right? Someone was like, I don't like XML. Well, 20 years ago, we put XML in everything we possibly could. Anyone remember those days? Anyone use SAML? Okay, so a couple people can feel that pain. I don't think XML was a great choice for SAML. I don't necessarily think it's a bad choice for Maven. If we built Maven today, maybe it would be YAML, and everyone would complain about that too, right? Yeah, so on GitHub, there are 60 million YAML files. There's 108 million XML files, if anyone cares. My only complaint, I really wish I could specify dependency in a single line, right, as opposed to whatever it is, 5, right? But other than that, I don't really mind XML. I think the problem that people have isn't so much that it's XML, it's that it's a non-programmatic language. But I think it's a good thing. So I think keeping that complexity out of your build is a win. All right. Anyone who spent any time with build tools probably has their own personal hell. All right. Mine's dependency hell. This is not unique to Maven. Every build tool kind of has this problem. A big part of what our build tools do is manage our dependencies. So your dependencies are a tree, right? Anyone run dependency tree before? Everybody probably, right? Yeah, it's probably the most run command other than install. I'll get to that in a minute. Okay, so your dependencies can have dependencies. Those dependencies can have dependencies, and so on, right? Those are called transitive dependencies. Again, I use this all the time to find out what odd things are coming into my builds. You can also use scans.gradle.com, right? So I got a flight here from my company, so I got to at least talk about it a little bit. This is a free service we have. You can see your dependency tree and all kinds of other information about your build. Go to scans.gradle.com. We'll show you how to do it. Come by our booth. We have t-shirts. They're cool t-shirts, and we'll give you a shirt. But again, enough about that. So your dependencies. So I stole this slide from Brian Vermeer a few years ago. Most of your application is made up of dependencies. It is not the code. That little dot in the middle is the code. That's probably what you spend most of your time like meticulously going over. Most of your app is dependencies. So you need to plan for security issues, whatever it is, right? Keep your dependencies up to date. Use a bot. Sneak has a bot, GitHub, Sonatype. I don't know. Everybody and their brother has a bot to keep your dependencies up to date. So go find something. But again, this isn't a security talk, but it's a public service announcement. All right, so let's get into it. So dependencies. Okay, so who's confused about dependency management? Okay, well, some people. So I'm not going to get into it too far, but kind of the quick overview of dependency management is it's kind of a default set of values, right? So if you had a POM and you stuck this in there, the default value for any time you use SLF for J simple would be 2.0.13 for the version and test for the scope, right? Somewhere later in your project, you're going to define this dependency like this, right? So nice and simple. It's only 4 lines of XML instead of 5. So what's going to happen is Maven's going to resolve, it's going to look up the version of the scope from dependency management, and kind of in memory, you might think about it looking like this, right? So the version is going to default to 2.0.13, and the scope is going to be test. So that's just kind of how dependency management works in a nutshell. It's a little more complicated than that, but that's kind of the quick high level. However, I want to point out my suggestion would be not to set the scope in dependency management. So I think when most people look at your dependencies, you automatically assume if there's no scope applied, it's going to be the default of compile. So I think leaving this line out would be to your benefit. That's, maybe you don't want to do that for JUnit, right? If all your projects use JUnit, maybe. But even then, I like to define it as test, just to make it very clear to the readers in the future of my POM files what scope that dependency is. All right, from the feedback this morning, no one has seen these memes, huh? A couple people? Yeah, I know you folks have, but Andres needs to step up his game. He's here, so if you see this guy, the small picture, not the other one, not Morpheus here, ask him about this. So essentially, I think these memes did a lot for helping people realize they don't need to do clean installs. But how many people here have kind of a clean install default in muscle memory, right? I do. I know better, and I still do. I know what these phases are, and I still hit clean install because my muscles that's what they type. So my theory on this is in the early days of Maven, we were migrating a lot of projects from Ant, right? Anyone use Ant? Oh, yeah, okay. We'd run into odd issues. You debug it for a few minutes, you get frustrated, you run clean, and then your build would work. Right? Pretty soon I pass that tip onto my coworkers, and they all do the same thing. And then 20 years later, I'm still typing clean install. Okay. So fast forward to today, most of those issues have been largely resolved, especially from the plugins from the Maven community directly. If you're using somebody's third-party plugin, you may run into some issues, but for the most part, you don't need to run clean. There are some cases where you do want to run clean. We talked about build cache earlier in the previous a couple hours ago. Sometimes you want to run a clean there. And again, if it's a third-party plugin that doesn't support clean very well or doesn't support incremental builds very well, then you may have to run clean there too. But you may not want to use those plugins either. All right, anyone seen this list of the Maven build lifecycle? It's a giant list. You copy and paste it from the docs, right? It's kind of intimidating. So if you run a Maven build, you're going to probably type in one of these words, and what's going to happen is Maven's going to run down this list until it gets to the one you picked, and it's going to run every plugin that's associated with that phase. So this is too much to look at, right? So let's reduce this down to what you get out of a typical default jar project. All right, so essentially what we're doing is we're going to copy resources from source main resources. We're going to compile some code. Then we're going to do the same thing for our tests. Then we're going to run our tests. Then we're going to build a jar file. Then we're going to install the jar file into our home directory, and then possibly deploy it to some Maven repository somewhere. Right? So where's verify on this list? Nowhere, right? So why do we say run verify? Okay, so it's right here. If you remember that long list, it was in the middle there. This is typically where we put the things that we care about with quality, right? So quality checks, code coverage, whatever other static analysis. If you're using failsafe or integration tests, it's in this mix here too. But by default, there's nothing bound to it. But running your build to at least this point gives you all of those quality checks. So what about install? Why do we say you don't need to run install anymore? Unless you're building multiple libraries on your laptop that depend on each other, you don't need to run install, right? In different Git repositories. Most of the time I work on libraries. I don't work on a lot of bigger applications. I work on libraries. And even then, I'm typically working on a single library at a time in isolation, so I don't need to run the install. So the idea is if you don't run the install phase, you can save that little bit of I/O, right? And maybe some disk space. If you're building giant WAR files, the disk space might be more of the issue, right? Anyone building giant WAR files? Anyone not want to explain it? Last time I gave this talk, somebody had like a multiple gigabyte WAR file, and we had a conversation afterwards. But it was fun. All right, so here's a build scan. This is just the timing. So there was an open telemetry discussion earlier. You could do something similar there. But essentially, this build from Apache Skimple is a small project. It's got 14 modules. It builds Uber jars, wars, a bunch of things. It took 0.13 seconds to run the install. So it's not really a big deal, right? It was a half a second to build the jars and 0.13 second to run the install. So it's not really a big deal. So if you run install, it might not be in the world. However, a few weeks ago, I was working with a customer. They were on some old NTFS system, and it took multiple minutes to build their jars and wars, and then a long time to copy running their install. So depending on your system, you may care a lot about that. I would also recommend your CI builds probably shouldn't be running install, especially if you're reusing your Maven home directory, because what's happening is you're installing things, you're basically polluting that home directory, so now you could have other artifacts in there that shouldn't have been in there. So not running the install kind of solves that problem. All right, now on to plugin configuration. So this is a little into the weeds, so I apologize for this. But I think some of the confusion around Maven is also related to how many different options there are to configure plugins. So you can configure a plugin kind of globally like this. You can configure plugins in plugin management, which is similar to what I talked about in dependency management. You can configure them in executions, and all of those options can be moved to various profiles. All right, I'm going to touch on profiles in a few minutes, but there's a lot of options. So if I take this configuration and I move it inside of that execution block, something changes, right? So if I run this plugin directly from the command line, I'm going to get different results for each one of those options. So the first one was the first configuration I showed. My configuration isn't applied. I think it's a 7-digit hash. I have no idea why this project picks the number 7 for a hash. I would have used 8, I guess. I don't know. That's a discussion for a different day. The second one is not going to apply my configuration, right? It's the same Maven command that I ran from the command line, but my configuration doesn't get applied. And then this last one is running the build as I normally would, and the result would be the same in both cases. I'd get my short hash. The configuration's applied. So my general suggestion is to apply plugin configuration globally, right? That way it's just easier for people to debug. There are reasons why you don't want to do that. If you have to run a plugin multiple times, you may want to split it up into multiple executions, each one having different configuration. But by default, keep it simple. All right, here's another conversation I had the other day, this week, about people complain that it's hard to add custom logic to a Maven build. Anyone agree? Not in this room, right? Good. Okay, so I think that complaint is related to kind of the XML issue, right? Oh, I don't want to write more XML. But if you already have a multi-module Maven project, you can just create another submodule, and you basically add a POM file in one small class. Right, so this is a simple Maven plugin. It's a few annotations. What is that? 6 lines of code, right? A couple annotations, and I'm taking a value, an expression, right? A dice expression. Everyone know what a dice expression is? Ooh, not enough nerds in this room. Okay, so mini lesson here. So this is from diceroll.dev. It's a dice parser. So 1d20 is one 20-sided die. 2d4 would be two 4-sided die. 1d6 plus 2 would be, I roll one 6-sided die and I add whatever 2 to it. All right, this is important information to know. Anyway, so I have a property that I'm injecting, right? I could set that property on the command line or my XML file, whatever it is, that gets injected automatically. Very much like Spring, Quarkus, whatever. Everyone's familiar with this kind of injection, right? So this is all it is. It's very simple to write a Maven plugin, so you should check it out if you haven't already. All right, so now we're going to move to a section called commit or omit. I am not going to claim that I came up with that name. I think it's clever, but I'm sure I heard it from somewhere else. So let's move on to a few things. Anyone want to guess what the first one is? Dependency ranges. Who likes dependency ranges? Excellent, excellent. You're looking ahead here, or maybe you read the comic. I don't know. So this is one of those hills I want to die on. All right, I don't think you should be using dependency ranges. My pet peeve is inconsistent builds. So I have a build, it works today, and it fails tomorrow because I use the dependency range or something else that there's some volatility in my build. What happens is you could have a build pass on your machine. A couple minutes later, you send it to CI, and the build fails, right? Because now Maven has resolved the dependencies different. Somebody updated a dependency, deployed a new version, and now your dependency tree is different than it was a few minutes ago. So maybe not a few minutes, right? Maybe it's 6 months. So what's happened to me before is I was working on a project. I had to go back 6 months into an old version of our code to patch a security vulnerability, just basic, updates of dependencies. And someone was using a dependency range, and that broke the whole build, right? It worked 6 months ago, and it fails today because of dependency ranges. So they look like this, but I don't want to go into it too much because it seems like everybody agrees with me. So obviously we're going to omit dependency ranges. Related to this though, anyone using the Maven wrapper? All right, a few folks. So I think you should be pinning the version of Maven you're using. So this screenshot is a little older now. You no longer need that .jar and .java file. So it's basically just a couple files. It's really easy to add the Maven wrapper to a project. But basically it's a way to help pin the version that all the developers in your team are using and CI. So it keeps everybody in sync. All right, so along with the version of Maven, you should be pinning the version of Java. Anyone do this? Maybe with SDKman or some other mechanism. Some companies, deploy VMs with a pin version of Java. You should be doing that. If you're building libraries and you need to support multiple versions of Java and multiple distributions, well, this isn't a solution for you, but it's a solution for a typical corporate environment. And again, there's other options other than SDKman. That just happens to be my favorite. Sometimes I'll create a .SDKman.rc file, specify the version of Java in there, and then I'm off to the races. So I'm going to say that one gets a check. How many people are still building with Java 8? Who doesn't want to admit it? Yeah, okay, so everyone's laughing, has something else they work on that also is building in Java 8, right? So we need to move forward. Maven 4 is going to require 17. But there are ways to move forward in your build. Newer versions of Java, newer versions of Maven will also make your build faster. So you should, this is a bit of a tangent, but you should update the version of Java you're using. All right, this is another fun topic that I like to talk about, but who has unit tests that connect to a database, a REST API, or some external service? Again, this is one of those things, who doesn't want to admit it, right? Many of us have unit tests that are doing something kind of beyond the scope of what a unit test is. I think in some cases that's fine. That's what you've decided on. But I think ideally you want to separate out your unit tests and your integration tests. Maven has the Surefire plugin for unit tests and Failsafe for integration tests. They are basically the same thing. They share like 99% of the same code. And it's basically, there's a little bit of sugar involved in Failsafe to do some other advanced things for integration tests. You can, if you separate them, you can actually get coverage for both. So anyone using JCON? Lots of folks, yeah, I love JCON. So JCON will keep track of the coverage separately for you and aggregate them together. So if you have 60% code coverage for unit test and 60% coverage for integration test, you just add them together, right? 120% coverage? No, right? So it has nothing to do with those numbers, right? You have to know what lines of codes were actually covered. It's at least 60%. It could be 70%. We don't know because you need a tool to merge them together. All right, so separate your tests. All right, who's using profiles? So, okay, a lot of folks, I think you may also be using profiles if you don't know it. Sometimes they're hidden in somebody's parent POM. They may be defined, but maybe you're just not aware of it. I've worked at shops where we had like a -p quick build where we compiled everything, ran a couple of smoke tests, and that was kind of the main way to get your application running. I like to do a -p CI build where I stick all of my kind of longer running things that I want to make sure run in CI, so all the static analysis, right, all those things. But I don't necessarily need every time I'm running a build, right? I want my build to be as fast as possible on my laptop, and if I want, maybe before I push a change to a pull request, maybe I run the -p CI to run all of the CI profile before I run, to make sure all my static analysis has been run. This is another technique to help migrate off of Java 8. So you can create a profile that will activate automatically for your later version of Java, so whatever, 11, 17, 21, whatever you're moving to, and you can add all the -add opens, right? Whatever you need in there, all of the hacky workarounds you need, and that'll help you migrate forward, and at least you get started. Okay, so definitely check out profiles if you haven't already. You can speed up your build, and you can do some cool things with them. All right, who has heard of test jars? Who's using test jars? Who likes them? Nobody. Oh, okay, yeah. A couple of Maven guys do. Okay, so I'm gonna apologize ahead of time. I don't like test jars. I think there's some fundamental problems with them, mostly based on how you consume the thing that's the result of the test jar. So I'm gonna save you a bit of complaint here, but generally I would suggest don't use a test jar. If you need to reuse a test, it's usually not that you want to rerun the test somewhere. It's that you want to reuse like a base logic, right? You have some base test class, or you have a custom JUnit extension. Stick all that stuff in a separate module, and then just use it as you normally would as part of your build. Okay, so I'm going to say omit. All right, there's another one I like to pick on. Who's creating Uber jars with the shade plugin? There's probably a few more of you don't know where I'm going with this, or do know where I'm going with this, right? Because he's punching himself in the face. I think if you use the shade plugin, you need to be very careful. I think if you're building something that's like a final artifact, or if you really know what you're doing, you need to hide some dependencies. There's some really valid uses for this. I think it's a very important part of the Maven ecosystem, but I think there's some problems with the general use too. If you're just creating a zip file with your classes and everything else you just throw in there. I have, Guava dependencies and all this other stuff. I'm just extracting and putting it into a zip file. My zip file is both huge and potentially has duplicate items, right? It makes it more difficult for vulnerability scanners. It doesn't work with the Java module system, and it can also just slow down your builds. So I'm going to say don't use them, but I think there's some pretty good workarounds. So I think Quarkus and Spring Boot both have a similar option. They create a jar of jars, which is very similar to a WAR file or a self-executing WAR file, if anyone remembers those days. But it's essentially a jar of jars with a special class loader that then just can load the jars inside itself, right? And that builds really quick. It keeps everything working with the Java module system. Vulnerability scanners know how to handle this. So there's a caveat here. There's some workarounds. So in general, be careful when you're building Uber jars. All right, how about source jars? Yeah, I love source jars. Okay, so if you have more than one project at your company, you should be building source jars. Everyone has seen this in IntelliJ or something like this. If you haven't, you know where the checkbox is in the settings, so you don't see this and it happens automatically. I swear I've clicked that checkbox 6 times, but normally I just click this button and the source is downloaded automatically. So what happens is in the background, my IDE goes out and gets the source jar from my Maven repository or Maven Central, and it loads that. And all of the Java doc, the context-sensitive help that you see in IntelliJ or Eclipse loads automatically. That's all from the source jar. So if you're pushing anything to Maven Central, source jars are required, right? So big checkbox here. All right, next one. Who's heard of reproducible builds? I know you 3 have. Okay, lots of people. This is awesome. Normally everyone's confused when I ask this. This is like the next best thing since sliced bread. I think so anyway, especially with kind of a security background. But those of you not in the know, I'll let you know now. Reproduciblebuilds.org is a great resource for you. Usually I have the URL here, but I forgot it. But so anyway, it's a practice. It's a set of practices that makes it possible to build your software multiple times and get the same output, usually byte for byte. Right. So what happens is if I build something from source and you build something from source, the same source, we're going to get the same output. Right. So that way, if we compare our jars, they should be identical. That way, I know you didn't inject anything malicious, and you know I didn't inject anything malicious in the build, and I'm a little happier with my supply chain security. So the reason why I'm talking about this is this requires you to have basically the same input source creates the same output, right? And, checkbox, obviously. So the same input creates the same output is also the same requirement we have for build cache. Anyone heard of build cache? Anyone who's been in the previous talk, right, a couple hours ago? So a build cache is basically a way to skip a lot of CPU intensive steps in your build. If you already run a clean build on your machine, you've populated a build cache, you run another build without any code changes, you probably don't need to recompile everything. Nothing changed, right? If I compile hello world.java, I'm going to get the same output every time. As long as I'm using the same compiler, the same dependencies, all those things, I'm going to get the same output. So I don't need to redo it. So a build cache can help me there. So there's 2 options. There's the Apache Maven build cache extension, which we talked about earlier, or Benjamin talked about earlier anyway. And there's the Develocity Maven extension as well. You can come find me later to talk about that. But basically, as long as the inputs are the same, the outputs are the same, you can skip steps and really speed up your builds. All right, this is true, right? All right, so who's running multi-threaded builds? Few folks. Okay, everyone else should be running multi-threaded builds. If you have multi-module projects, you should at least go check it out. All right. If you have a big 1-module Maven project, you may want to split that up. That will help with build caching as well, and potentially running your builds in parallel. If you have a build that looks like Project A, where let's assume app depends on impl, depends on API, what's going to happen when Maven runs that build? It's going to run the API build, then it has to wait and run the impl build, and then wait and run that build. So that Project A cannot be run in parallel, right? It's sequential by default. So if you have a project like that, you might be out of luck for running it in parallel, but a build cache may help here. And if you made a change to app, you could skip the first 2 modules. If your project looks like module B, let's pretend that web app depends on service, core, and utility, and then all of those depend on model, right? So what's going to happen is Maven's going to build model. Once that's done, it's going to build service core and utility all at the same time. And then when those are done, it's going to build the web apps, right? So now I've sped up time because I've at least saved a couple leaves of my build. All right, and of course, if you have a much more complicated graph, there's potential that things could run in more parallel than my little example. This example fits on the screen though, so if you have 300 modules and you can fit them on the screen, send me a screenshot. I'll use that next time. All right. So I mentioned running things in parallel. Again, Benjamin and Martin talked about running tests in parallel as well. Anyone running their tests in parallel? Wow. You should be running your tests in parallel. I'll get to some caveats here. But Maven has a lot of options, potentially too many options. If anyone saw Benjamin talk about this morning, he kind of hit on the same note. So you can have a single JVM run multiple threads and run all your tests at the same time, or you can fork multiple JVMs and they can each run tests sequentially, or of course you can do them both at the same time. You can fork multiple JVMs and each one of those could have multiple threads. So there's a lot of options out there. I'll have a link at the end, I think, that points to some documentation to get you started here. But you have to watch out. It's not just as easy as enabling parallel flag, right? Anyone have hard-coded ports in their tests? Nobody, right? Of course not. Yeah. Setting system properties, whatever system-wide settings you have that may cause conflicts between when tests run. You may run into issues when you enable parallel testing. JUnit 5 has a lot of great options to help you work around those if it's only a handful of tests. So go check that out. I think cleaning up your tests to make them run without any other dependencies is a good thing anyway. So that also makes your tests run in parallel, but it's good test hygiene. So anyway, go check that out. Everybody's build will speed up if you have a multi-module project. Enable the -- threads command and then run your test in parallel. All right, so I'm wrapping things up here. So here's a few things to check out. So this was also covered this morning. So Maven Daemon, anyone trying this out? Maven Daemon yet? A couple of people, awesome. All right, so I'm really excited about this, but essentially the TLDR here is we're gonna keep Maven running. The JVM is warm, it's warmed up. It's gonna be optimized already. All the just-in-time compilation has happened. This requires using Maven 3.9 or 4.0. And you can get this from SDKman 2. It's MVND. If I don't know why I didn't put that on the slide, but Maven Daemon, if you Google it, you'll get some great instructions. And how about Maven 4? Anyone try out Maven 4? Just the 3 people who work on Maven 4. Awesome. So I'm really excited about Maven 4. There's going to be a talk in an hour or so, or whatever, an hour and a half-ish. So definitely go check that out. I'm really excited. The thing that excites me the most is we're basically breaking up the POM file. So right now, if I have a project that I want to publish to a Maven repository, I define my POM file, and then when I publish that same POM file to my Maven repository, right, or Maven Central. That means that POM file, that structure, the model, can never change, right, because we want it to be backwards compatible. If we change that structure, that'll break Gradle builds, it'll break SPT builds, it'll break Maven 3 builds, right? So it's set in stone now. For better or worse, that's where it is. I don't know, Maven became too popular, and this is just what we have to deal with. So now we're breaking that up, right? So now, basically, when you publish to Maven Central or your internal repository, we can create a backwards compatible POM, and that means we've split the model up, and then the model you build with, your build POM, can add a lot of sugar to it, right? So maybe I can define my version just once instead of once in every file, right? So there's a lot of little things like that we can do now that we've broken them up. Things like Gradle and SPT, they don't have this problem because they generate a POM, right? So that's basically what we're gonna do. So go check out Maven 4, check out the talk in, what time? 4 o'clock. All right, so now this comes to the end here. Hopefully, if anyone has questions, you can yell them out afterwards. But before we get to that, I have a giveaway. So obviously we have a booth. I work at Gradle. We have a booth. You can scan this code. You'll get these slides. You scan this. There's also a link to what we call the build speed challenge. So you take a build. You can take a project of yours. You can take a sample project. I don't care what it is. You basically add build caching to it. You send us a screenshot. You mail it to us, and we send you a swag box that's got a t-shirt and socks and stickers and stuff in it. And of course, it works with Maven, right? But we'll send that right to your house, so don't worry. And again, we have t-shirts, really cool t-shirts at our booth, so you can get one here and there. But yeah, so that's that. The slides, everything that I've talked about should be through that QR code. All right, so I'm going to try to use this Slido app here, but if anyone has any questions, I think I've got a few minutes here. We can answer the questions. Anybody? Clear as mud, right? That plugin section was tough, right? All the XML. All right. Well, if nobody has any questions, I appreciate everyone's time. So thank you.